So, good day everybody, my name is Petr and I work for Disney Streaming Services. You know, we are not as cool as Pixar or Marvel or anything like that. You know, and also I have like nothing to do with Star Wars, so if you wanted to ask me like how lightsabers work or something like that, I will not be able to answer that. But we do interesting stuff as well. We are working on a platform which enables us to deliver like real-time streaming data to like thousands of users across the world. And as you would assume, a significant part of this is built using JVM and Scala and all these things. And now the topic of this talk, adopting GraalVM. Graal is a new platform developed by Oracle. It includes a new compiler and runtime and some like other things, which I'm gonna like mention later. This project has been around for a while, but a couple of months ago it started to look like more like promising project to let's try this. So I decided to check it out, and I would like to share my findings with you. Lastly, before we go on, I like to say I have like no affiliation with Oracle or anything like that. So there are multiple reasons why they decided to write a new compiler / VM from scratch. And I think the main one was that one of the compilers, C2, reached the end of its life cycle. It is very difficult to do any bigger changes there. Actually, very little was done there in the last few years. It is like quite old code written in some legacy C++ dialect. And you know, there are like very few people who like really understand how it works. Like C2 was an extremely successful piece of code, but it's time to move on. So Graal, run programs faster, anywhere. That's the official slogan, and I bet it makes sense. What is really good is that Graal is written in Java using the new JVM compiler interface or JVM CI. Of course, it is not as cool as it was written in Scala, but it has like a lot of advantages, like much lower entry barrier for engineers. You know, there are like thousands of smart Java developers around. Apart from that, it also provides, you know, inbuilt memory safety and all these like Java traits. Lastly, its performance. I think like a lot of people may be worried about Java's performance and like potential overhead, but Java is quite decent these days. You know, these 20 years of development, you know, brought some fruits. So I don't think we need to like worry about this too much. And as you can see in the picture, GraalVM is supposed to be a platform for different languages and environments. And in this talk, I go through the topics which I found the most interesting for us. But before we do that, I think it's important to discuss licensing. Graal is available in community and enterprise versions. And the enterprise version is like strictly better, you know, it's faster, more performant, has more features and things like that. But if you want to use it in production, you have to pay for that. That's how it works these days. Okay, that was it. And now let's take a look at how Graal can help us with compiling. You know, it's compiling in Scala, so I think devstar makes total sense. Actually, I wanted to do the old "why is Scala compiler so slow" joke, but if you look at the results which I got from my browser, it doesn't look, you know, too bad for Scala, which was quite surprising for me. But anyway, I think we all agree we would like to speed up our compiles, and GraalVM can help us with that. So if you're using SBT and want to start using Graal, you just need to reference a correct archive like this and pass these flags. As you can see, it is still marked as experimental, so let's set up the expectations correctly. About the archive, Graal is a part of JDK since version 10, so in that case you can just use the flags, or you can use dedicated Graal archive directly. This archive is based on JDK 8, and this may be actually easier for you, because making your Scala project compiling with JDK 10 or even JDK 11 may be quite an interesting exercise. I think for starters, the easiest way is to add the flags and the Java home path to your SBT ops. And for your Java home, I would recommend using the Graal archive directly, so to make it as simple as possible. If you decide to go with JDK 11, you need to use Scala 2.13, and this might be a little bit challenging, mostly because of limited library support. Scala team maintains the list of available libraries. I have the link in the reference slide in the end. Alternatively, you can use Scaladex, which is the index of Scala libraries. And you can search it by target version, which is quite handy in this case. Either way, you should definitely check the libraries before committing more time into it. I tried it on one of our projects, to be honest, quite a new one, and it took me an hour or two to make it work. You can also expect some glitches on the road, like disabling some optimizations and things like that. But it should be fairly doable. Of course, this very depends on your particular project. And now the promised compiler speed up. This benchmark was run by Virgin, who works for Oracle. As you can see, there is a significant speed up, and I have the link to this article in the end as well. I definitely recommend going through it, but honestly, I was way more interested in how it looks like in my projects. So what are we compiling here? It's quite a decent project, basically a bunch of microservices written in Scala, of course. The code itself is functional. We are using libraries like Play, AKHTTP, Cats and its effect library, Doobie, and many others. And I'm very happy to say that we were able to see consistently better compile times using Graal. The speedups around 10% are quite realistic, which is really good. So that was compiling, and now let's see how we can use Graal as a JIT compiler for runtime. But before we do that, let's have a super quick recap regarding just-in-time and ahead-of-time compilation. Traditionally, JVM uses JIT, or sometimes called dynamic compilation. It has certain advantages. The compiler can work with runtime information and also perform aggressive optimizations and also de-optimize if needed and all these things. On the other hand, we have ahead-of-time compilation. Basically, everything is compiled statically before the execution itself. Obviously, it has way more time and resources when doing this in this way. This was not very common for JVM. AOT using Graal, by the way, was added in JDK 9, I believe, but I don't think it was widely adopted. So if you want to use Graal as a JIT compiler, you need to run your binaries with, these flags, of course. But before we dig into it a little, let's take a look at this. It is a super simple algorithm for getting primes, which I plan to use for various exercises later. As you can see, it just generates a stream of numbers, which are filtered by this function. Again, like no rocket science. Like it's quite functional, but that was probably the only requirement. And everything is limited to the max constant. This is going to be different for various exercises I plan to show you here. And lastly, as you can see, I'm not even using the results, so it is like really a let's warm up my CPU type of thing. So I tried that using these two distributions. And as you can see, the numbers are slightly different than we would hope for. So what went wrong? Like, of course, like the test is nonsense. We cannot measure performance like that. Honestly, I expect you guys to start like booing me immediately. But anyway, we need to tackle this like slightly differently. So take a look at primes version 2. From the functional perspective, it does exactly the same thing. I just move the stuff around a little bit and skip some lines. Mostly because like slides are like not big enough. But I also added JMH annotations, so we can test it a little bit more like seriously. And as you can see, the results are quite different now. If you look at it, it looks like really well. Like, of course, you may be wondering, what about our real services? So as you would expect, we spend quite a lot of time testing because we are providing real-time content and we cannot just like start breaking things. We tried a small subset of our services in our QA environments using Graal, and it looks quite decent. But I think we need to like dig a little bit deeper before we push it forward. Graal is a project in its early stages, but there are already production deployments like Twitter, and that's it. I have not found anyone else. If you guys know about someone, let me know, please. As I briefly mentioned before, we have AOT available since JDK 9, but that was based on an older version of Graal. But the project I wanted to like show you here now is like way more ambitious. It is called Substrate VM, and it basically allows you to compile JVM apps to native code without any dependencies on the JVM. So you really get a single statically linked executable out of it, which is pretty cool. To do so, you just need to take your jars or class files or whatever and use native image binary which is shipped with Graal. And this may be quite an elegant way how we can solve some typical JVM shortcomings, like slowed starts or massive jars or things like that. So the primes again. This time I lowered the max to 8, so we are really measuring just startups. And as you can see, the difference is huge. I would say, as expected, to be honest, it works very, very differently. I was also wondering what happens if I move the max to something like 100,000 or something like that, because in theory, JIT should usually outperform AOT in long-running benchmarks. But I got this, incorrect memory access. It happened because JVM and substrate VM use different object layouts, so memory offsets calculated during the compilations were incorrect. This is like well documented, and it is like not too hard to fix. But like that's not my point here. My point here is to show you that you cannot just take like any program and execute it natively. It cannot work like that. There can be some refactoring work involved, and some things like may not be like solvable at all. As you guys would suspect, substrate VM has certain limitations, usually given by its AOT purpose and by the effort to keep it like small and concise. So for example, it is not possible to dynamically load classes because AOT compilation works with a closed word assumption. Also, like invoke dynamic is fairly limited for the same reason. Similar classes or fields, things accessible via reflection must be known ahead of time. Or JVM TI, JMX, and like other native VM interfaces, these management / debugging APIs requires access to Java bytecode, which is like no longer available at runtime. Yeah, and so on. I have the link to the corresponding substrate VM page in the references section, and I would definitely recommend like going through it, so like you won't get surprised later. And now some use cases. Like obviously, the most common use cases are like small programs or scripts, anything you want to start up quickly, and you do not expect to run it for longer time periods. Also things like Alexa apps, for example. Without that annoying, you can even have Java / Scala AWS Lambda without the annoying cold starts. There is an excellent article about this, how to make this work using Go runtime. It's also like in the references section. I really recommend like going through it. I'm not saying like it's like super useful, but it's like definitely super interesting. I think the key question here is, and like not just for the Lambda thing, but like for the majority of the use cases I mentioned, do you want to use Scala in these cases? I don't want to like start a religious war here, so I leave it up to you, but like think about that. So we went through the topics I found the most interesting, but Graal offers more, like often focused on polyglot programming. And as we are at Scale by the Bay, I think it makes like sense to like go through it really quick. You may like Truffle, which is a language implementation framework. Basically, when you define your language using Truffle, it will use Graal as a JIT compiler for the language. Graal already has implementations for JavaScript, Ruby, R, and Python. And we will likely see more implementations in the future. The languages in GraalVM can like work together. There is an API which lets you run code from one language and another one. This lets you write, true polyglot programs. And also you can take advantage of common tooling, among these languages and, things like that. Personally, I believe that from a long-term perspective, like this may be Graal's largest added value. Then we have Suong, which is a LLVM bitcode interpreter. Using Suong, you can run languages which can be transferred to LLVM bitcode, like C++, for example, and zillion others on GraalVM. Another interesting component is MLE, which basically allows you to run GraalVM in the Oracle database. So for example, you are able to run the same validation function in front end and also in the database, which is like nice, but it's also like a vendor lock. Anyway, as you can see, the original motto, run programs faster anywhere, makes quite a lot of sense here. And now the summary. Graal has many promising features, and according to my opinion, it has massive potential, but it's like a still bleeding edge technology. But I think it's like worth giving it a shot. Thank you. Yes, no, yes, no.
Questions, anyone?
Can you give more details about why you need to go Scala 2
I think Scala 2.13 already requires that, or vice versa. If you want to use JDK 11, you need to have Scala 2.13, right?
Do you know why? Do you know what features it calls?
I'm not sure.
Because a particular problem here is there's a lot of people trying to version of Scala with Spark. So Spark was only just migrated to 12.
Yeah, if you want to use like Spark with 2.13, I think.
Well, it's not that. There's things like our library because people like using Spark. So like yesterday, Chris was saying that Twitter is running on Graal. So I just want to tell you there seems to be a lot of limitation going to 2.13 if you need to use Spark.
Yeah, I'm not from Twitter, but I'm pretty sure that I use like 2.12, because like if you want to go for 2.13, you basically are forced to use like milestones, release candidates, and like version for that, and not just for Scala, but also like for all libraries pretty much. So it's like quite risky, to be honest.